Okay, let's get started. So we're already done with the first 4 weeks and are now on week 5. And week 5, we're just going to be reviewing and practicing with loops. So let me just pull up the notes from last time to get this going. Okay, so all right, so what did we talk about last time? I told you about loops, and are basically just ways for you to have something repeat a bunch of times. If you've done any other programming language, the two structures that we use, the for and the while, are pretty much similar. The one thing that I missed to tell you last time is there's a do-while loop also. So after I review all this stuff, I will tell you about that too. That's the one thing that's different in C++ that you probably have not seen in Python if you've done Python already. Okay, so again, what is a loop? It's a way for you to repeat something a bunch of times. The general format for a for loop is as follows. You have a for, you have parentheses, then you have some kind of a variable. You can declare the variable in here. You can declare the variable before the loop, right? You can do int I here, and then you can just use the variable, or you can declare the variable inside the loop. Okay, whenever you declare a variable inside of a loop, it can only be used inside of that loop. Okay, so if I have a variable called, let's say, apple, all right, and this here is an apple, and this is also an apple. And the name for the variable is pretty arbitrary, whatever you want to call it. And then later on, if I wanted to try to use this apple somewhere else, let's say cout apple equals apple, right? We have a problem. Why is that a problem? Because I have declared this variable inside of my for loop, which means that it can only be used inside of these curly brackets, which is the definition of a local variable. What's a local variable? It's a variable whose scope is only the section of the code where it was defined. I can also go and define another variable, let's say, for example, here. All right, so int orange. All right, if I try to use orange here, just like I did with the apple, all right, let's try orange. Same deal. All right, it doesn't like it. If I try to run the program, it'll give me this error message right here. All right, what is the error message? Use of undeclared identifier orange, right? And you might think, well, I declared it. Yes, you did declare it, but that's inside of the curly brackets of the for loop, which means that this variable belongs only to the for loop. You cannot use it outside of it. Okay, so that's your first introduction to the scope of different variables, and then we'll revisit this once we get into functions so that you see how that applies. Okay, so a variable declared inside of a loop can only be used inside of that loop. Alright, so the general format for a for loop is you have some kind of a variable and you give that variable a starting value in the beginning of the loop, right? Then you give it some kind of a value for which it will stop, and you have some kind of an increment or step, whatever you want to call it, at the last one, right? So the first two have a semicolon after them. The last one does not, and you do not want to put a semicolon after a loop, because if you do that, things stop working. For example, you can see that this thing here is now not happy. The I is not declared if I try to run the code. So basically, no semicolon at the end of for loops, or any kind of a loop actually, except the do while. Once I show you that, you'll see. Okay, so this is the general format for for loop. And anything that you do with a for loop can be written using a while loop. Okay, so basically this loop on the bottom does the same exact thing that the one on top will do, except you have to break it down into separate lines. So this line right here is the same as this right here, this line right here is the same as this right here, and the last line right here is the same as this right here. Okay, so for some of you it might make more sense to write a while loop, and in my past experience, many students are more comfortable with the while loops because it kind of breaks it down into little pieces. But generally speaking, if you know how many times something is going to happen, like you know where it starts, you know where it stops, you know by how much it will increase or decrease, then use a for loop because it's just shorter code, better practice. Okay, you can have this thing increase by +1, right? If you want the thing to increase by +1, you do a +1. If you want to increase by +2 or some other number, you can do that. Instead of doing +1 like this, you can do ++. That also works. Instead of doing +1, you can do plus equals 1, which is what you've done in Python if you took Python. Okay, so both are valid, or all three are valid. I personally like the shortest one, this one. If it's going to increase by 1, just do the ++. Okay. But I'll leave it like this for now. And yeah, if your increment is going to be about +2, you cannot do the ++ anymore, but you could do plus equals 2. Okay, that works. And the same thing with a while loop, right? Basically, you just tell it, go increase yourself by +1. Okay, anytime you have some kind of a variable is equal to itself plus some other number, what will happen is the variable will increase its own value by its old value by some other number. Could be increasing it, could be decreasing it. That's also known as accumulation, right? And the shorthand notation for this here is, if you want to, plus equals 2, right? Same thing as the other one that you're seeing. Okay. In addition to this, you can have your loop work backwards. So this is a loop that starts at 10, stops, basically goes on until I is greater than or equal to 0, and goes backwards. Okay, if I don't think through completely about what I'm trying to do with my loop, I could create some kind of a never-ending loop. What will happen if I do this here? Goes on forever, right? So it starts at I is equal to 10, goes on while I is greater than or equal to 0, and then it just increases itself. So it'll go 11, 12, 13, 14, 15. It will never go back. It will never go to 0. So it will go on forever until it runs out of memory. The operating system shuts it down. Okay. So be careful how you think about these loops. Well, if you see something just running thousands and millions of times, break the program. Stop the program. And the same thing that you see on top, written using a while loop on the bottom, right? Basically the same thing. You're starting some kind of variable at 10. The loop is going to go while that variable is greater than or equal to 0, and the variable decreases its own value by -1 every time. Instead of doing -1, you can do j minus minus. That also works. You can also do minus equals 1. Okay, so 3 different ways to do the same thing. Okay, so this is, again, it could be j minus minus, and it could also be j minus equals 1. Same thing. Okay, same as this. All right. And here I guess I was demonstrating to you how that variable I cannot be used outside of the loop. Why? Because, again, like I mentioned in the beginning, it's declared inside of the loop. It's local to the loop, right? And the scope of that variable is that loop. Okay, so it's important for you to learn these terms: scope, local, undeclared, declared, because if you don't, you're not gonna be able to figure out how to troubleshoot your own programs. Okay? And best way to learn is just break the program. Right? Try different things, see if it works. If it doesn't work, now you learned a new way how things shouldn't be done. If you want to, you can also have these loops happen as many times as the user wants to. right? All you have to do is start the thing at 0 or 1 or whatever you want. Make the loop go on until the thing is less than or equal to some stop value, which will come from the user, and you tell that variable to increase itself by +1 every time. So now this is a loop that happens as many times as the user wants to. Okay. When I run this loop here, it will basically show me as many numbers as I want, separated by comma, and in fact, why don't I just run it? All right. So if you look at this thing here, where is that one? Where's the one with my commas? If x is equal to stop. Let me see where this thing is. See out here. Oh, I'm supposed to enter. All right, 4 times. Right? So the first loop right here on the top, right, shows me all the numbers separated by comma, and I have an extra little comma at the end. This other loop underneath it shows you a number followed by comma if x is less than stop, and otherwise it shows you just the x with a new line. And that is how you get rid of that last comma at the end that was right here. Okay, so just another example. And then I have some other loop in there underneath it, more examples basically of the same stuff. I showed you a never-ending loop, right? This was the never-ending loop, right? It starts at 0, tells it go on while you're greater than or equal to 0, and increase itself, increase your own value. So it will never go back. It will always be greater than or equal to 0. So the loop will always continue to work, and that's pretty much it. That's what I told you. Another thing that I mentioned last time was how to use a generic never-ending loop to go on until a user enters a certain value. So you can tell a loop to go on forever by just saying true. You can also say something like 1 equals 1, which is also true, right? You can also even say just 1. That will also work, but let's just go with true. This thing here shows you how to count values that are odd or even, which was your hint for P23. All right, the user enters some kind of a value. If they enter a 0, right, what you're going to do is you're going to break. And the effect of the break is the loop stops right here at line 141. That's it. As soon as you enter a 0 value, you hit the break, you're out of the loop at that position, at that particular position. So that means everything after it is not going to show, it's not going to happen. And then underneath it, I have a way for me to count if something's odd or even, right, or even. So if any number modulus 2 is equal to 0, so if it's evenly divisible by 2, then that's an even number. Okay. There's also a continue, and what's the effect of the continue? As soon as you encounter the continue, the loop resumes from the beginning. Okay, it goes all the way to the top and starts cycling again and again and again. So break exits the loop right here. Continue makes the loop go back all the way to the beginning. Okay, and of course we're going to check by all the way in the back in the beginning. I mean, it will go all the way back into the condition. It's going to see if this is true. It is true. It's always true, and then goes on and executes the rest of it. Okay. So one thing that I showed you was this here. This will only show if I do not enter a 0, which is going to exit the loop, or I do not enter a 1. So if I enter 0 or 1, I'm not going to get to this line here. If I enter any other value, I'm going to get to see this little hello message every time. And then there were some examples in there that I showed you. Let's just do a 0. All right, I did some examples with the currency conversion. Right, you had the little label on the bottom, on the top, and all the numbers underneath it. I showed you how to format your output so that it preserves the the lineup of these columns. If I do not use this either this notation right here, so there's 2 ways to accomplish this. One way is using the C++ way. So this is your C++ way, right? And the other way is this right here, which is the C way, right? So C++ is backward compatible with C, which is the older language upon which the C++ was based. So you can use all the features from C in C++, but you cannot use the C++ features in C, okay? Because C is the older one. It doesn't know anything about these new features, okay? So whether you do it this way or do it this way, it's the same thing. For me personally, it's kind of easier to do it with the older notation, with the printf. And if you're going to be taking Java, Java has a printf too. And if you're going to be taking Python, Python has a printf too. It's not printf, it's print, but it's the same format. So it's pretty standard across different languages, okay? And that's why I'm using it. So how does it work? %3i tells it reserve 3 digits for whatever number we're going to insert here. And what number are we going to insert here? Well, the first variable or number that was listed here. So if I put some number like 3, then the number, or let's do 10, right? That number 10 will be inserted right here, and we're going to reserve 3 spaces for it once we show it. And the next one is %.2f. The %.2f tells it we're going to insert a float or a double. It works either way. Basically a decimal number, and that decimal number is going to be rounded to 2 digits, right? If I change this thing to 3, then I'm going to see 3 digits, okay, after the dot. So I'm leaving it as a 2. And what number are we going to insert here? Well, the second variable. So first variable gets inserted wherever the %3i is, and the second variable gets inserted wherever the %.2f is. So that's a little something about you formatting the output in certain ways. Underneath that, I showed you how to show all the different characters all using an ASCII. So I showed you how to do A through S. And how do I generate this? I look at my ASCII table. What was the ASCII table? It's in the assignment. It's a table that shows you that every key on your keyboard has its own numerical representation. For example, uppercase A is 65 and uppercase S is 83. So I can create a loop that goes from 65 to 83 in order for me to show the letters from A to S. And then once I generate those numbers, I use char to cast them. What does it mean to cast? Cast means I'm temporarily forcing the ASCII variable, which is an integer, to turn itself as a character or show itself as a character. I'm not changing the original data type of ASCII because that's impossible in C++. I'm just casting it, which means I'm turning it into something else temporarily. So I'm turning every number into an actual character, and I'm counting every number that I show. And if I count 4 of them, I show a new line, and then I restart counting. Okay, so that was that. Another thing that was kind of pretty important was finding sum, average, smallest, all that good stuff. Right? So here it is, a loop that happens as many times as the user wants to, right? K starts at 0, while k is less than x, k plus plus, so the loop will happen as many times as the value x for whatever the user enters. We're going to add all these different values into my sum variable. Sum starts at 0, so we're basically just accumulating every value that is being entered into the sum variable. And that's the easy part. Now the next one, which is also not hard, is to find the smallest. And we have this algorithm to find smallest, which is basically as follows. We're going to do, we're going to create a variable smallest, right? We did. And then what we're going to do is we're going to make it equal to the first number that was entered, right? How do we know it's the first number that was entered? Well, the first time we go through the loop, k is equal to 0. Right, so if k is equal to 0, we're going through the loop the first time, which means that the num, whatever the num is that the user entered, is the first number that they entered. So if k is equal to 0, smallest is equal to num. In other words, smallest is equal to the first number. Else happens for all the other numbers after the first one. So if it's not the first time we go through the loop, which is when k is equal to 0, then we're going into the else for all the other numbers. And if any other number is less than my smallest, that is my new smallest number. Okay? And I had like a little example in here on the top, right? You have these numbers, 4, 3, 2, 1. Initially, you're making the smallest equal to 4. then, so these are numbers that the user is going to enter. The next number that the user enters is a 3. So as soon as the user enters into the 3, enters the 3, you go into the else. So, and you're checking, is 3 less than 4? Yes, it is. So now the smallest is equal to 3. Then you go to the next one. You go into the 2. That you're still going to jump into the else. Is 2 less than 3, which is what the smallest assumed last time. Yes, it is. So now smallest is equal to 2, etc., etc., etc. It goes through the list of the numbers, picks off the smallest one, retains it, and when the whole thing is done, you can see that smallest is equal to the smallest number. Okay, and the finding the largest is basically the same thing. You're just going to make another variable, call it largest, right? And you're just going to go in there and add another if. If num is greater than largest, then largest is equal to num. Okay, so that's that. I won't leave this here. Take it out. Okay, so that's important. And then the average of all the numbers is, well, the sum of all these numbers that the user entered divided by x, which was however many numbers the user wanted to enter. So if they enter 4 numbers, 1, 2, 3, 4, the sum of those 4 numbers divided by 4 is your average. Okay, and that was pretty much it, what I told you last time. And like I mentioned, there's one thing that I forgot to mention, and that is a do-while loop, right? And the do-while loop is actually handy for validation. And going back to the validation thing, I'm going to go all the way at the top, right? Which was this little thing here. All right? Where's my H? There you go. Okay, so basically a while loop that we use for validation. We're not going to get too fancy. I have some examples in there for you how to handle errors in C++. So if the user goes in there and enters, if the user is supposed to enter an integer and they accidentally go in there and enter a string, program will most likely crash. Okay, if C++ feels like it. Okay, but in order for you to prevent the crash, what you can do is you can handle the errors. And it's a lot more complicated than what we did in Python, if you took Python. It's a lot more complicated than what we did in Java too, if you took Java. So I'm not really going to get into that because it's not that important how you handle an error message in C++, but I do have some examples throughout the class content, and you'll find it at some point. Okay, what I want to show you is just basically just the basic input validation. We're assuming that the user is going to enter a value. They know they're supposed to enter a value, because we maybe told them like whole number. Okay, so the user knows to enter a whole number, but if I'm using an if to validate their input, if they enter an age which is less than 0 or an age which is bigger than 123, we are going to catch that. We're going to tell them invalid age, but if somehow they accidentally enter the wrong value again, the if is only going to work one time. To fix this, we change it to a while. Okay, but what happens is if you notice, we're kind of using the same thing twice. So I'm doing one input basically here, and I'm doing another input down there. Okay, so what I'm going to do is I'm going to change this to a do-while loop. Okay, so I'm just going to rewrite this thing to a do-while. Okay, so let's say int capital Age. Alright, that's the age. And then I know that I'm going to be entering some kind of I'm going to ask the user to enter something no matter what, right? So I'm just going to say do, curly brackets, and then I'm going to grab this thing here. I'm going to copy it, paste it right there on the bottom. And it's got to change to capital H. Okay, so, and this is the only time that you actually have to put a semicolon. Why? I don't know. Okay, it's C++, join the club. Sometimes you have to do semicolons after a loop. Most of the times you don't. Okay, so you have to remember. The only time you put a semicolon after a while loop or any kind of a loop is when it's a do while. Okay, and what is a do while? Do while is a loop that happens at least one time, right? So we're going to have to ask the user to enter at least one value, just like, you know, this thing right here. I'm going to copy this, I'm going to paste it right there, and comment this thing out, and now it's an age, right? So enter an age. I'm going to ask for this, and if it's an invalid age, we're going to loop and loop and loop and loop in here forever. Okay, so it's just a way for you to shorten the code. Okay, so use a do while. Use a do while when you want to validate user input. Question?
Between ages less than 0 and ages greater than 123, what are the two lines?
What are the two lines? Okay, this is your OR. All right. This here is OR. All right, and how did the OR work? This whole thing here, you have two conditions sandwiched in between these two vertical lines. So either this is going to be true and this is going to be true, or this is going to be true, this is going to be false, or this is going to be false, this is going to be false, or this is going to be false. I mean, false, true, true, false, 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 true, true. Right? Those are the possible combinations. And the only time this whole thing is going to be false is if both of them are false. In other words, the only time the loop will stop happening is when the age is not less than 0 and the age is not greater than 123. Okay? So this is the OR logical operator. Okay? And if you forget these, then go back to the first week that we talked about ifs and selection. So, all right, the first week, week number 2 is the first week that we started talking about selection, and in there you can look at the lecture notes and the video, and you kind of had to, we actually skipped this one because of, there was like some kind of a holiday or whatever it was that day. So for your Monday section, you can go to week 3, and I covered it for the first time here. Okay, but you're welcome to look at the other one. You know, the lecture notes for the Thursday section is basically the same as yours. I have all this stuff here. So intro to selection, right? The different operators, right? We had the relational operators, and we had our logical operators, right? The logical operators were the two ampersand signs, that's your AND, the two vertical lines, that's your OR, and there's the exclamation thing, which is a NOT. So if you want to make sure that something is not equal to something, you make an exclamation in front of the equal sign, and that is not equal, right? Just a quick review, right? Because if you have that question, I'm sure somebody else does too. So again, this is your truth table for an AND, right? So we use an AND to check to see if a value is within an acceptable range of values, right? If you want to see if something is between 18 and 21, you use an AND, okay? So the way it works is you have some kind of a condition, some other kind of a condition sandwiched in between an ampersand signs, and this happens to be false unless both of these conditions are true. So we're only going to do whatever's inside of my if when both of these things are true, which is different from how my OR works, where the thing happens to be true for every case except when both of these things are false, right? And what is the practical use of these things other than constructing logical, statements in your program? Well, one practical application for an OR is check to see if something is outside of an acceptable range of values, right? So in this case, if something is less than 0 or bigger than 123, maybe we want to trigger some kind of an error message, okay? And beyond that, you would write your code the same way as you would think about things, right? If I walk with this certain speed and I start running or whatever, then something else starts happening. The same way you would think, that's how you write these logical statements. Okay, so that's why there are logical operators, and again, there's relational operators, logical operators, and there's also arithmetic operators. Okay, So that's where that is. So this week, now that we're done with reviewing what I told you about last week, by the way, any other questions? We're good? Okay. So practicing repetition, and then next week we're going to start talking about functions. Let me see what I have here from the older lecture from way back in the day. Yeah, accumulation, finding the max, nested loops. Did I show you nested loops last time?
Yes.
Okay, good. So, yeah, what's a nested loop? Well, it's one loop which is inside of another loop. So the one that's inside will happen a certain number of times. And then when this one is done its magic, we're going to go back to the outside loop, which is going to go and do its next iteration. So every time you go through the loop, that's called an iteration, right? There's iterative constructs, so there's ways for us to iterate through things, which is basically loops. And there's also ways for us to recurse through things, which is another way for us to repeat something a bunch of times. Okay, and I'll tell you about that when we get to functions. Okay, yeah, that's about it. So, I'll let you read this chapter 2, computer hardware, in your own time. There's a quiz that goes with it, right? So read this chapter PowerPoint, answer the quiz on the bottom. If for some reason you don't do well on the quiz, I have set them up to unlimited attempts. So if you don't like your score, take it again and again and again until you get a better score. And the highest score counts. And if you really want to get a perfect score, you might want to look at the answers after you've done it the first time. Okay? Yeah. Any questions about computer hardware? Okay, well, let me ask you this. Is a 3rd generation processor any faster than a 6th generation processor? No. Right? Everyone aware of that thing? In fact, I have a student who's taking my data structures class who just bought himself an Alienware laptop. All right? And what's an Alienware laptop? Not an Alienware, sorry, Edge. You have an Edge too, don't you? Razer, whatever, same thing, close, right? Edge, that's what I meant. So those things are expensive, right? He paid, I think, like $3,000 for that thing, right? And of course, the first thing that I do when I look at the computer is I look at the processor. Seriously, that's what I check, right? And if you want to, let's say, too bad I can't see. There's ways for you to look at the processor information on a Mac. You actually have to go into the terminal and type a certain command. I forget what it is. But you can actually pull the specs of your processor, right? Let's say, for example, I go to Lenovo, because I can. All right, we're going to go to Lenovo, and we're going to look at, I don't know, products, laptops. ThinkPads are usually the best ones they have. Unless they have some other ones. ThinkPad laptops. I think X series, no, T series, T. What's the workstation model?
W. This one's
They don't have W's anymore though.
No?
I don't think so. I don't think it's.
the T series then.
Yeah, that's what I'm. P. What about P? Oh no, P. See, this thing's got 17-inch screen. Finally, they brought them back. I like bigger laptops. If this thing came with 17-inch, I'll get a 17-inch one. All right. Huh?
I liked it until I started carrying it around.
Yeah. What bigger is better. They even had some ThinkPads back in the day that had like a little screen that falls out. So that was awesome. It was a 17-inch laptop with a little screen that falls out and you can see more. Anyway, so what we're going to do is, man, these are Xeons. Let me not look at the Xeons. Let me look at something less powerful. Let's go with T series. All right. So if I'm buying a computer, right? Like let's say I'm going to buy this thing right now. I'm going to look at the first thing I'm going to look at is I'm going to look at my processor specs. Okay, before anything else. And by the way, what generation processor is this? The generation is indicated with that first number here, right? So what generation do you think this is? 7th, right? So 7th generation processor, and too bad I don't have my old ThinkPad here. But hold on, let me just grab this thing. I'm going to search Google for this, and the first thing that shows up right there on top is the CPU benchmark. If I click on this little thing here, you're going to see the benchmark. Okay, so if you really want to compare apples to apples and oranges to oranges, you look at the benchmark of the thing, right? And the benchmark on that guy's laptop who had paid close to $3,000 for it was, I think, $8,600. Okay, and I promise you, you can go back to a 3rd generation processors and you can find ones with benchmarks that are in the 9,000s. Okay, so the speed of the actual processors has not improved a whole lot since a long time. Okay, they have figured out how to put more of them in a smaller space. They have figured out how to make them more efficient, but they're not any faster. Okay, so if you're going in there trying to buy a new laptop every couple of years, you're wasting your money, literally. They're not increasing in performance that much. As far as the CPU is concerned, memory has gotten faster, the hard drives have gotten faster. Just while we're on that topic, there's 2 kinds of hard drives. Well, there's more than 2, but generally speaking, there's a solid state drive and there's your old hard drives. Right? The old hard drives are what all these computers in the room are using. Most of the college computers that we have will probably have a real old hard drive, which is basically like a record player. It has a disk, it has a little arm that moves around, the disk spins, the speed of the hard drive is actually measured in RPMs, just like your car that has an RPMs. That's how fast the disk rotates. The faster it rotates, the faster you can load up programs, right? So a lot of times, not a lot of times, but when you turn on your computer, let's say you have Windows, right? You turn on the computer from scratch, and a computer starts booting up, and you have to wait like a minute for Windows to load. What you're waiting for is you're waiting for the operating system to be loaded from the hard drive into RAM. And if you have a faster hard drive, the faster that computer is going to start up. So on an old hard drive with like 5,000 something RPMs, it'll take you like a minute for the thing to boot up. You switch to a solid state drive, which does not have any moving parts. It's basically the same technology as your little keychain USB drives or whatever you call them, right? That thing might load up in 10-15 seconds, right? If you have a virus scan that may take like an hour on a regular hard drive, you switch your hard drive, you swap it to a solid state drive, that virus scan is now going to be like 5-6 times faster. And they have only gotten faster and faster. So really, other than the processor, another important thing to look at is what kind of hard drive am I getting, right? Am I getting a solid state drive? And if you're not, you kind of, left in the dust. You're gonna have to wait a long time. Anytime you open a program, you're gonna have to wait for that program to be pulled from the hard drive, loaded into RAM, and that's the wait, right? So most of the times, the bottleneck for most of the things that you do, unless you do some crazy gaming and video rendering or whatever, is the hard drive. So if you want to improve your computer's performance, take out the hard drive, put a solid state drive, and it's going to fly. Okay? Another way for you to improve the performance beyond upgrading the hard drive is getting more RAM, right? Because everything is loaded from the hard drive into RAM, and RAM is a lot faster than the hard drive. You need, if you want to have a whole bunch of things open, like I have, like a million tabs and a million different apps with a whole bunch of different things in them, you need to have lots of RAM. What's a good amount of RAM? I would say at least 16 gigs nowadays. Okay? If you're going to run virtual machines and stuff like that, I actually have one of those ThinkPads with 32 gigs of it. Right? Why? Because I like to have virtual machines. I want to run Linux. I want to run whatever I want. Okay, so different virtual machines allow me to run multiple operating systems in the same computer, right? In fact, I have a virtual machine on this thing here, and I have one for Windows 10. Right? This is VMware right here, so I'm just loading up Windows on the side, and yeah, I'm still using the Mac. And by the way, you can do the same thing for Mac on a Windows, right? It's not exactly legal, but it can be done, right? It's called a Hackintosh. All right, so you basically find yourself the operating system and put it in a virtual machine, and there it is. This is the virtual machine. And the reason I want lots of RAM is because this virtual machine, Windows, will probably want at least like 4, 5, 6 gigs of RAM. So from whatever 16, this thing has 16, that's the most it has, because it's Mac, and they never figured out that you need more than 16, because they're geniuses. And that's why people were making fun of Apple, like on the most recent update, because even the latest and greatest Apple, I don't know if it finally upgraded to 32 gigs, but they were stuck with the 16 gigs limit forever. Okay, so anyway, so that's why you want lots of RAM, so that you can run virtual machines, so you can have a lot of things open at the same time. Anyone know what happens when you run out of RAM? I have 4 gigs and I'm already using them all up. What is my computer going to do?
Slow working.
Huh? Slow down. So what happens actually is it will slow down. It might stop working. It might crash on you. But what happens is the computer says, all right, I'm out of RAM, right? And then what it's going to do is it's going to dedicate a part of your hard drive and treat it as RAM, right? So, and it starts basically treating the hard drive as RAM, but guess what? The hard drive is like 10 times or more slower than your RAM, which is why it takes forever for things to load. The computer freezes. If you're on a Mac, you got the beach ball of death. If you're on Windows, you get some other stuff. What is it? A blue screen of death or whatever else, right? So that's when things start crashing and stuff like that. Okay? So hard drive, RAM, processor, and last but not least, video card, right? I went cheap on this laptop here, and I really do regret it, because for the purpose of this class, I have to render a bunch of videos, right? So what happens is when I start running my computer, when I start running the rendering of the video, it sucks up all my processor power, right? So what happens is this computer has an integrated video card. And what's an integrated video card? The video card is part of the motherboard, right? The motherboard is where everything is connected. That's where the processor plugs in. And actually, technically speaking, you could say that an integrated video card is part of the processor pretty much. But really, it's part of the motherboard. And if you're trying to render a video or play a game or whatever, you're using up your processor to handle all the video tasks. If you want to improve the performance, if you don't want the computer to be getting all superheated and to be doing things faster, get a discrete video card. Right? Discrete video card is a special little card which plugs into the motherboard, separate from the processor, and handles just the video tasks. Okay? I figured I'm not going to need it. What am I going to do this for? I'm going to save like $300-400 or whatever, but I wish I got it. Okay? The only disadvantage of having a discrete video card is maybe your battery life will go down if your computer is not smart enough to switch between the integrated and discrete video cards. And there's different kinds out there. There's NVIDIA, there's the AMD, and I personally like the NVIDIA better. Right? I've never been much into the AMD because I had maybe 3 or 4 AMD cards and they all went bad on me. Okay, and then I finally switched to NVIDIA and it was perfect. But at the same time, I know people who've had opposite experiences. So whatever. If you want better video performance, rendering, gaming, that kind of stuff, 3D building 3D things, you might want to get a video card. Okay? So if you have any questions hardware related, let me know. But that's pretty much in a nutshell the things that you're probably not going to learn in the chapter, but now you know a little bit more practical information. So if you're going to be buying a laptop, don't listen to the salesman or whoever's trying to sell you that garbage. Look at the processor model. In Windows, it's very easy. Look at the system, and then in the system menu, it shows you what the processor model number is. If you're on a Mac, just Google it. How to pull the information for the processor is just you go in the command line, you type a command, and it shows you the processor. And then you look at the benchmark, and basically anything over 5,000 is decent. If you can get something like 10,000, you're flying. Even more than that, good luck finding something like that as far as laptop is concerned. But for desktop computers, you could build these kind of things. And as far as RAM, maybe at least 16 gigs if you can afford it. Maybe at least 8 at the very least, right? All right, so that's the hardware business that I want to tell you about. And now let's talk about this week's assignments. Okay? So, what I'm going to do is, I'm going to comment out a whole bunch of things here, because I don't want to see them. Yeah, I'll just take out everything because this is all the stuff from previous lecture. And I'm going to leave the do while loop because that's the one thing that we did today that was new. Okay. And let's do the hints. Okay. And just to remind you, make sure that your indentation, you're using proper indentation when you write these programs. Okay? Everything that is inside my main is equally spaced from the wall, right? From the left edge. Okay? Whether you use 2 spaces or whether you use a tab to line things up, doesn't matter as long as it's all consistent. Everything that is going to be inside of my loops is also indented equally. I don't have this kind of a business going, right? If I see this kind of stuff, if I see like one, maybe in the whole program, I might let you slide. But if I keep seeing that you're not lining things up neatly, I will catch you. I'll tell you, fix your indentation, and I'll take off some points until you get it right. Okay, so it really helps, especially if you have big projects, thousands of lines of code. Nobody wants to read this kind of a stuff, right? You take this to your boss and you give them your code, and they'll be like, just go back, fix your indentation, and add some comments too. Okay? Commenting your code is very important because nobody wants to sit there and try to figure out all the clever things you did. They just want to read, oh, this is what you're doing here. Okay, good, I believe, and then move on to the next thing. Okay? All right. So let's do hints. So P26, number guessing game. All right, write a number guessing name, number guessing name, great. Number guessing game. That's what I meant. Okay? Number guessing name, that doesn't make sense. So the computer will generate a random number between 0 to 100, right? The user will be prompted to guess the number. If the number guessed is greater than the random number, an appropriate message will show. And so let's say what you can do is to kind of cheat so that you know what the number is. You can show yourself the actual random number that was generated, and then try to guess it, right? So let's say this is the random number. You try to guess it the first time. It's 50. You're giving it as a 56. Then a message should show up. No, it's higher than that. Then you try to generate another number. I mean, it's the same number that you have generated. Now you're trying 85. It'll tell you, no, it's lower than that. And then if you finally guess the number, you got it, right? And so other than this, other than giving them these messages, right? No, it's higher than that. No, it's lower than that. You're also supposed to tell them, correct, you got it, and tell them how many guesses the user took. Okay? And this, by the way, is an example of a binary search. Okay? And binary search basically means, let's say, for example, I'm thinking of a number between 0 and 100. What will be your first guess? 50, right? What you want to do is you want to go at the middle, right? And I'll tell you, no, it's lower than that. So now you know the numbers between 50 and 0. What will be your next guess? 25. So you just keep dividing these, range of numbers in half, and you go in the middle. Okay, so for at most, the worst case scenario, if you're thinking you can guess a number in less than 7 tries. So between 100 numbers from 0 to 100, if they are in order, right, if they're sorted, you can guess them in at most 7 tries using a binary search. Okay? There's also just the random guess. You can just keep guessing numbers from 1 to 100. And then, if the number is 99, you can basically guess 99 times wrong. Worst case scenario. So binary search, very efficient way to find a number. That's what we're doing here. So I guess let's do a little bit of this. So this is your P26 hint. P26 hint. Okay, so I have I don't know how we're gonna make a random number. I have all the business in there, stdio. I also need to use include time age to get the time, and I think that's maybe it. stdlib, one more. Include stdlib. I think that's the one. Just in case, I can't remember. Okay, so these two are just for me to generate a random number. In fact, let me just take this one out. It might work without it. Okay. So first, I make some kind of a number like int IC is equal to time null. This pulls the system time. Then I do srand and I put the IC in there, and then my random number. Oops. Now random number between 0 to 100, right? It goes int random num is equal to rand modulus what? See if you remember. 101. Excellent. Right? Another way to do this, you can say, all right, 0 plus this if you want to keep it consistent. 0 is the first value, and the 101 is the second value minus the first one plus 1. And it always works out the same way. Okay, so now we're making a random number between 0 to 100. I'm going to do something like cout. The number is, and this is just so I'm cheating basically, right? Because I don't want to try to guess it for real. Random num and del. And then I set up basically a loop while I should have some other number int guess, right? And I can make the guess equal to -1, so that way they're never equal to each other, right? Since this thing is going to be between 0 and 100, this is going to be -1. I'm going to set up some kind of a loop like while guess is not equal to my random number. Okay, so it's a loop that will go on forever until the user guesses the thing. And I say something like cout, enter a guess, all right, or guess the number. Okay, and then cn, the guess, and then if the guess is less than my random number, I am going to say it's higher than that, right? So cout, no, it is higher than that. Okay, and in fact, why don't let me change this loop to something else. I'm just going to make it a while true. All right, goes on forever, and then if my guess is equal to the random number, then I'm going to break this thing, okay, or stop the loop, okay? And in any other case, I can just count the thing. So I'm going to have another variable, count, which is equal to 0, and if I basically did not guess it, and if it's not higher than that, then it must be count plus plus, right? So count the guesses. And at the end, then of course you need another if, right? Need another if for when the number is lower than the guess, all right? For a lower number, for lower than that. Okay, and at the end you just show how many times you guessed, and that's it. Okay, so that's your binary search. What I'm going to do is I'm going to take this thing out because I don't want to run it. Take my word for it. Most likely it works. The next one. And do I have any kind of a hint there? No. So your hint's in the video and probably in the lecture notes too. So, whoops, quiz. Go back. 26. All right, 27. All right. Write a program that generates x random numbers, or x random integers num is a random number between 20 and 50, x is a random number between 10 to 15. Calculate and show the smallest, largest average of all these, right? So we already had a similar assignment where the user had to enter, basically, the user had to determine how many times the loop is going to happen, which was the x, and then the user had to go in there and enter each of these individual numbers. But now we're changing it. We're saying the loop is going to happen a random number of times, and the numbers we're going to generate in it is going to be a random number of numbers, but they're going to be between 20 to 50. Okay, the loop itself is going to happen between 10 to 15 times, just because. Okay, no good reason at all. I guess I'm going to give you a hint on that too. So 27 hint. And by the way, for your own sake, so, some people are wondering, oh, how do I, write my descriptions or whatever. Just grab this whole thing here, go in your code, right? This is my description. So this is your P27 hint, all right? And so for my description, I'm just going to go in there, I'm going to copy paste the whole thing, paste it in there, all right? Might want to fix my indentation or whatever, but probably don't have to because it's all the way at the top. Put everything on the same line, all right? Not on the same line, but get rid of the extra spaces, and just have that stuff inside your assignments, right? For every one of your assignments. Now you don't have to worry about, oh, what am I doing? Just look at the description. All right, so there you go. This is my description. This is what I'm supposed to be doing. This is how the program is supposed to be running. Okay. And one thing I should warn you about is don't try to fake your output. Okay, because it has happened in the past. Okay, it happens every semester. A student will run the program is not going to work, and they try to fake it on the bottom, like, oh yeah, look, I entered this and it's working. I'll tell, right? And if I catch you doing that, you're going to start losing your resubmission attempts. Okay, so every assignment that doesn't work, you're welcome to fix and resubmit, unless I catch that kind of stuff. Okay, then you lose that resubmission. Okay, so if it doesn't work, just ask me. Hey, I wrote this and it doesn't make any sense. Why it's not working? I'll help you. Okay. So anyway, all this stuff is in there. So what am I supposed to do? Oh, and also try to fit things on the same. Fit it as wide as the screen is. Right. Normally, no more than 80 characters. If you're less than 80 characters, and by the way, you can tell the characters right here on the bottom. All right, this is 66, 81, so I'm already, if I go one left, now it's 80 characters, 79, 78. So keep it at 80, no more than 80 characters wide, right? Unless something crazy happens, like you have that program with the astrology thing where you had something and something, or something and something else. If it makes sense to have it one big line, that's fine, but generally speaking, try to keep it like this. All right. So what I'm going to do is I'm going to use parts of this thing here. So I'm going to take it here, right? So what don't you like? What the hell? Let me do it again. So I'm just going to copy this. I don't know why it's complaining. So 27, oh, I know why this was missing. I'm going to take out this to be here. Okay, so basically you need these two lines, right? Need the below two lines to make a random number. Okay, I need that in order for it to be a truly random number, otherwise it's not going to be random. All right, so in this here, I'm saying we're going to have a num, which is a random number between 20 to 50. So all we do is you do int. Well, I'll do it on the bottom. I'll get rid of the sample run. Save real estate. Okay. So x is a random number between 10 to 15. So I just go, all right, int x is equal to rand. And how do I make a random number between 10 to 15? Help me out.
10 plus rand.
10 plus rand, what? 6?
16?
If I say 16, then it's going to make me a random number between 10 to 25. So yeah, 6. Okay? So that's my random number x. And then that is how many times the loop is going to happen. For int whatever. Z is equal to 0. Z is less than x. Z plus plus. And then I go in there and I say I make another random number. Let's have another number here. Int num. And then in here I'm going to make a num is equal to rand. And this time I want a random number between 20 to 50. So how do I do that? Plus.
Rand modulus 31.
Yep. Okay. So 20 plus rand 31. This thing makes me a random number between 0 to 30. I add 20 to that. Now I get a random number between 20 to 50. Okay? So that's it. And then it'll be the same thing as the other one, right? So it's basically the same. The algorithm is the same as finding smallest and largest as before, which is basically, right? Make smallest equal to the first random number, right? Compare smallest to all other numbers, and if any other number is smaller, that is your new smallest. Okay? So, and it also helps for you to kind of visualize how things work out. Remember, I always recommend just start with something simple. Maybe you don't even want to make a random number, but let's just say, all right, this is going to be like 4. It's not even 4, it can be a 4. But basically start with some sample numbers and see how it will work for them. I'm not going to do that. So this is algorithm to find smallest. And again, how do I know? Let me make this different. So this one is z is equal to 1, while z is less than or equal to x. Okay? So my question is, how do I make smallest equal to the first random number? Let's see if you remember how you did your other assignment. And I guess the question is, how do I know that num is, which num is the first random number? What indicates that num is the first random number?
And z equals 1.
Correct. So if my z is equal to 1, right, this is true the first time we go through the loop, and I'm going to say, okay, well, in that case, smallest is equal to, let me make a smallest in there. Okay, smallest is equal to that number. Okay, smallest is equal to the first random number. Okay, and then for every other number, then compare smallest to all other numbers. Else, right? Curly brackets. I don't like how it does this, but let's live with it. Okay, so else happens automatically for all other numbers after the first, right? So if z is not equal to 1, if it's not the first number, that means it's all the other ones. So then we just compare if smallest, or not smallest, if num is less than smallest, or capital num, then smallest is equal to that number. Okay, so if any number is smaller, this is your new smallest. Okay, that's the logic. And the same thing for largest. Okay, So that's it. That's your hint for P whatever 27. Any questions? So it's important for me that you know how to find these things. You know how to you know how to find the smallest and the largest and do the summing things. Okay. These are some of the important things that you gotta master at least. Okay. So that's that. And I'm going to take this out now. All the way here. Take my words. It most likely works. Let me put 3 of them here so it stands out. And 3 of them here so it stands out too. So 26, 27. Now we're doing, let's see if you need a hint on the next one. Next one, 28. Okay. So do I have a sample there? No. Okay, so this one is basically some kind of a program that is going to compute a gymnastics competition score. Okay, there are 4 judges, and each judge can give a score between 0 to 10. And you're going to average the score of 4 different judges. Okay, so this is going to be user input, no random numbers. So we need to make sure that the user doesn't mess it up, right? So if they give, if they do a negative 43 or something like that, then you shouldn't count that as a score, right? You should ask the judge for another one, right? So then the judges enters a negative. You tell them no, you must be between 0 to 10. Then they enter a number that's bigger than 10. Again, you tell them sorry, it's got to be between 0 to 10. Then they enter the 5. Then you go to the next judge. They enter that judge enters 8. Third judge messes it up, gives an 80. You give them another try. Now they do a 7. Fourth judge enters a 10. And then you show the average of all these different judges. Okay. So there's a couple ways to do this. But since we're doing loops, it makes sense for me to show you the most efficient way. Right? So you could have 4 separate loops for each of the judges to make sure that each of them gets the input correctly, and you can have 4 different variables for each of the judges and all that good stuff. Okay? But we're going to do something else. So this is P28. P28 hint. Okay. So what I'm going to do is I'm just going to have an int judge score. That's it, right? And then maybe I'll say judge number, and I think that'll do. Okay, so then I'm going to make judge number equal to 1. Since I know I have 4 judges, I'm going to make a for loop for judge number is equal to, well, I guess I don't have to do that here. So judge number is equal to 1 until the judge number is less than or equal to 4, and then judge number plus plus. Okay? And then first thing I'm going to do is I'm going to do, all right, cout judge, and then I'm going to put judge number, enter score, right? And I'm going to do a cn and judge score. Okay? So, I go in there, I'm going to test my program. Alright? Damn it, that whole age is haunting me again. Let me get rid of this one. There. One more time. Okay, so judge 1, enter score, okay, 10, 2, 3, 4, right? So it basically works for all 4 judges, 1, 2, 3, 4, right? Okay, so the next thing I'm going to do is I'm going to make sure that I'm going to make sure that it is a valid score. So what I can do is I can say, all right, if my judge score is less than 0, or my judge score is greater than 10, and let's throw a set of parentheses around this because some compilers are picky, and then 1 extra parentheses, whoops. Alright, so if that's the case, what I'm going to do is I'm just going to say continue. Go back all the way to the top. Okay, and let's see how that works. So my idea is if they enter wrong score, go back to the beginning of the loop. Let's see what happens. And this is the incremental development, right? I'm not going to come up with the solution all at once. I'm going to come up with little pieces. I'm going to test them. And if they don't work, I'm going to adjust. And probably it's not going to work. So this is judge 1, big number. Now it's going back to the beginning, but notice what it's doing. It's going for judge 2 now. Okay, so what I'm going to do is I'm going to prevent this thing from going to judge 2, because every time when I tell it continue, it goes back to the beginning of my loop and it checks to see if this is true. Judge was 1, it's less than or equal to 4, increase it by +1. Okay, so what I'm going to do is, before I do the continue, I'm going to tell it to reduce the judge score by 1. So I'm going to say judge score minus minus, right? So hopefully now the second time I run the program and I enter some garbage for the first judge and I go back to the beginning of the loop, it will go from judge 1 to judge 0, then,
Should it be judge number?
Yes, you're right. Judge number. Judge number minus minus. Okay? So if my judge number was 1 and we entered garbage for that one, right? Then I'm going to reduce the judge number to 0. It's going to go back. It's going to check, is 0 less than or equal to 4? Yep. Increase yourself by +1. So now it's judge score. Judge number is 1 again. We go back to the beginning, and hopefully it works. Some big number, some big number, some big number, some big number. Okay, so that works. Okay, and then I can go in there, and then if it is a good score, we're not going to be in here, right? So we're never going to hit the continue, and then I'm going to say maybe I should have total. Total, right? Make the total equal to 0, and then my total is equal to, let's write it the long way, total is equal to total plus judge score. And that's it. Okay? And then you show the total divided by 4, and that's your average of the 4 judge scores. What's another way to do this? You basically have kind of like a do while or some kind of a while loop for each of these judges, and you're going to have 4 judge variables or maybe 1 judge variable, and you have to do the same thing many times, right? But the reason why we learned for loops is so that we can save some of these repetitions. Okay, so that's 28. Any questions? All right. Next one. 29. Practice arithmetic. Okay, so the arithmetic business goes like this. You're going to ask the user if they want to add, multiply, subtract, etc. Right? And you're going to generate 2 random numbers between 0 to 9, and you're going to ask the user something like, what is 2 plus 2 equal to? Right? If the user gets it wrong, you repeat the same question again until they get it right. Right? So, and then you ask them, would you like to try again? If they want to try again, you go back and you generate 2 new random numbers. If they get it wrong, you repeat the same question with the same random numbers. If it's incorrect, you do the same 2 numbers again and again and again and again until they get it right. Okay? And then finally, once they get it, you offer the option, would you like to try again? If they don't want to try again, then you stop the game. Want a hint on that one too? Anyone want a hint on this? All right, Rigo wants a hint. I aim to please. So, okay, so this is the P29. Okay, so the arithmetic business. Let me grab that random number that I had in there. Oh, I already had it. Okay, so I'm going to have, let's say, int num1 is equal to a random number from 0 to 9. Was that what it was? 0 to 9. Okay, so rand modulus 10. All right, that's the first one. And this is my second one. And then I'm going to do something like, let's say, int operation, right? and I guess this is the user enters this, right? So 1 is plus, 2 is minus, 3 is multiplication. You don't have to do division. Okay, so just addition, subtraction, and multiplication. So if my op is equal to 1, this is for addition, what I'm going to do is I'm going to ask them something like cout what is num1 plus num2, right? Something like this. Okay, and then I do another integer, let's call it answer. Okay, I go in there, cin, answer, and then I'm going to do a loop while the answer is not equal to my num1 plus num2. Then I'm going to repeat the same question over and over and over again. Okay, I grab this thing, and I'll say something like cout incorrect. All right, and repeat the question over and over and over until they get it right. Okay, and then when this whole thing is done, you do all right. Now they got it. When they're done with this loop, that means they must have guessed it, right? And then you say, all right, cout, you got it, something like that, and then you ask them, cout, would you like to repeat? All right, and if they want to repeat, maybe we have another variable here. Let's call it repeat. Okay, and if my repeat, maybe I'll have something like 1 is no, right? If repeat is equal to 1, I'm going to stop this loop. Which loop? I don't have a loop yet. So what I'm going to do is I'm actually going to grab this stuff here, and I'm going to put a while true here. I'm going to put all this other business underneath it, all the way down to, I don't know, where's this end? That's the if. There we go. It actually indents it for me. Nice. Okay, so this loop goes on forever, right? In it, we're going to make these numbers. We're going to ask the user if they want to add or whatever. And then I guess in the beginning, yeah, you want to ask them what they want to do. They want to add, subtract, or whatever. Okay, so cout, do you want to add, subtract, multiply, something like that. Okay, and that's it. That's basically it. So that's your arithmetic problem. Okay, not very hard. Some people find it hard. Some people don't. Okay. All right. Next one. 30 penny that doubles or $1 million. Okay. So this is just a basic loop that has something double over a period of time. So how many times is the loop going to happen? 30 times. So I go in there. Almost done. This is P30 hint. All right, so you have a loop for int day is equal to 0. Let's make it 1. Day until the day is less than or equal to 30. Day plus plus. And inside this loop, you have a penny. So I'll do a penny, double penny. I'm going to make it a 0.01. And then here I'm going to say show how the penny doubles every day. All right, so the penny, show the penny for 30 days, and say how much or less the value of penny is at day 30. Okay, so maybe you can throw an if in there, or something else, but I'll leave that like that. I'm not going to give you more on that because that's pretty much, I don't want to solve the entire thing for you. Okay, 30, 31, dice, another random number game, right? You make 2 random numbers. What is it? From 1 to 6, right? You the player have a choice to keep your dice. So you make random numbers, random numbers. You make, say, 1 and 1. And I asked you, do you want to keep them? You say no. Roll again. 2 and 2. Do you want to keep them? No. Roll again. 1 and 6. Do you want to keep them? No. Roll again. 6 and 6. Do you want to keep them? Yes. Then the computer gets 2 random numbers. Let's say the computer gets a 2 and a 4. And then you compare who wins. You had a 6, 6. The computer has 2, 4. So you win. Okay? So that's that. I'm not going to give more hints for this because we're running out of time. Checking the type of triangle. Right? So basically the user is going to enter 3 sides for a triangle, and you have to check to see if the triangle is a right triangle, or if the triangle is an equilateral triangle. And that's about it. Doesn't even have anything to do with loops. Okay, it's just ifs. Okay, so that's that. And then last one, 1 through 1,000 x per line. So this is similar to that other one that we looked at with the ASCII characters, 10 per line, except this time we're going to be showing numbers, just numbers, and it's going to be as many numbers per line as the user wants to, except you have to make sure that the numbers per line can be between 10 to 30. So you're going to ask the user how many numbers per line they want to do. If they want to do 33, you tell them no, it has to be between 10 to 30. If they do 2, you tell them no, it has to be between 10 to 30. If they give you 12, then you show all the numbers from 1 to 1,000, 12 per line. Okay, and I have some hints there on the bottom so that you can get started, which is this stuff is similar to the ASCII stuff. So the sample that I have here is basically, this is 4 per line, right? Instead of using the number 4, just use whatever number the user enters, and then you're done. Okay, questions? That's all I have for today. And we're done. 1 minute over. So, come see me in the office if you have any questions. Send me emails if you have any questions. Go see the tutor if you have any questions. STEM Center. Okay? So, thanks for coming, and I'll see you next time.